Hey, hello there. Today I'm looking at question 648, replace words. So the question is as follows. In English, we have a concept called root, which can be followed by some other words. So the root is a word. The root word can be followed by some other words to form another longer word. Let's call this word successor. So the successor is the longer word that's formed by concatenating two words. The first word is called root. So for example, the root in followed by other can form another word. It just so happened that another word is another. So I think the n here should be prefix. The other here is the actual root for this word. So I'm just gonna do replace words myself for about this question description. I will replace all the roots with prefix. So keep reading. Now, given a dictionary consisting of many roots, many prefixes, and a sentence, we need to replace all the successors in the sentence with the prefix forming it. If a successor has many prefixes can form it, we will replace the word with the shortest prefix we have. So that's what the question is asking. Looking at the example, we have the sentence, the cattle was rattled by the battery, and we have three different prefixes, cat, bat, and rat. So we'll replace cattle with cat, replace rattled with rat, and replace battery with bat. There's no word with multiple prefix, so there is no conflicting about, there is no need to see which prefix is shortest or something like that in this example. So basically, for this question, we're just going to chop this sentence into individual words and map this word into some kind of replacement function. In that function, we're just going to check the word we'll search for. We'll try to do replacement with all the prefix we have. If we do find exactly one prefix that the word starts with, then we return that prefix. If we find multiple prefix, maybe we have cat, cat, or a single C, we return the shortest one. So for this case, if we do have another C as the prefix, we return C. If we don't find any prefix, we just leave the word unchanged, just return the original word. So we map that replace function to all the words here and collect the result and piece them together. That would be the approach to solve this problem. So the only thing here is that how we actually going to code this replacement code to have that to be more efficient. Of course, we can do the brute force to just try all the pairs, all the prefix, and just try to see if the word starts with those. But a better approach is to create a try for all the prefix, so that all we need to do is to just traverse inside the try using the characters in the word. So if we do find a try node which with a termination flag, end of word flag, that means we have a prefix that matches the word we are looking for. So in that case, we will just return the pass in the try that leads us to the termination flag. So if we do have a try here in this question, we will have a pass that's root C A T. If we search for cattle inside the try, we would follow the route to node C, node A, node T, and node T we have an end of word flag. So with that flag, it will indicating that the path from the root to that node CAT, or it's just the path that the characters we looked at from the word. Until the time we see the flag is an actual prefix that matches the word. So if we use a try, it would just be linear time search with respect to the length of each individual word. And for the whole sentence, it would just be linear with respect to the length of the sentence. That's the runtime complexity if you use try. So, but use try, we have additional time and space complexity to create the trie. The trie is going to be the size of the input dictionary in terms of both the time to construct it and also the space to store it. But with that, the search for the replacement in a sentence will be linear with respect to the length of the sentence. So if the sentence can be super long, using in a trie could be more efficient. So that's pretty much the big idea about using trie to solve this problem. Yeah, so let's code this up. I'm just gonna maybe code the bigger idea first, and then try to finish the details. So we initialize a trie data structure, create an object from the class, and just for I'll do a little bit change here. I think this should be prefix. I will code an insert function for the trie to insert a pass that corresponding to the prefix. So that's that take care of the trie search, and then we're just going to return space, join together all the words that have been passed into some kind of a replacement helper function. So that's the workforce. The workforce for this problem is going to be this replacement function. So it will take a word and try to return its replacement. So for this, we're just going to traverse inside the trie. So for I character enumerate over the characters in the word character by character. If the character is not in the trie node, that means the current pass inside the trie is not a valid prefix for the word. So in that case, we'll just return the word itself. We don't do any replacement, and this join here will put that word back into the modified sentence. Otherwise, we will just keep traversing. Once we move to the next node, we want to check do we have an end of word flag. If we do have one, that means the pass right now is the prefix for this word. So since we also have an index iterator here, we're iterating over the pairs of index and character. So from the beginning towards here is the actual prefix. So we just return this. So that's the replacement. Of course, to facilitate this, we have to actually code up the trie data structure. So here, now our constructor is basically create an empty root node. We'll define this node object inside the trie class, which I would just as my code yesterday, I'm just gonna subclass the default dictionary. And we will have a end of flag, that end of word flag for this node. So everything has to be false. It's initial to be false. So that's the trie node and the constructor for the trie. All we need is to have this insert function. The search function is implemented inside the solution here. we would basically just for all the prefix we have, we will try to insert that into the try, and at the end of each prefix we will flag that to be the end of the word. So when we actually search for the word, if we just follow the character by character in the word, if we find it under a word flag inside the try node, we will return the portion of the word upon until that point. So I guess we could move this onto the try, right? So I would just call this search then, or replace. Replace is fine. So we'll just replace this with self.root. Yeah, so that's so I would just call this try.replace. Okay. Let me see if I have obvious problems. So this replace function is just gonna, starting from the root, enumerate over character by character inside this word. So it will be something like CATTLE. So the first iteration we grab C, which the I is 0, and we see do we have a C node after the root, which we do have one. So we will just move to that node and test do we have an end of word flag. Obviously we don't, so we move to the next character, which is A, and just keep going on until we find the character T. If we find the character T, the node would have an end of word flag, so we return the portion of the search word upon until that position, so it will be CAT, the actual prefix. So it looks fine. Let's try run it. It's working. Nope, not working. What's the problem? Okay, I see. I should convert this to list, I guess. So the map object is none type. So why is that? What's this test case? So it's a lot of prefix, and the search word are quite long. What do my code outputs? The expecting a string instance, but I got a non type. So which is the problem here? It seems that if I split by space, we do have a bunch of words. Could it be that after this for loop I'm not returning anything? So I don't have neither the end of word or it could be that my word is actually shorter than a prefix, so that I do have partial march with the prefix, but I don't even meet the shortest prefix. So the word is actually shorter than the prefix. So let's, if we have a single character like C here inside this input sentence, the replace will return nothing. Okay, so to catch that, I will just return word as the last resort. So I don't need this map, right? I don't need this list conversion, right? So let's see. Yeah, this time it's working. So yeah, this return here handles the case. Cool. Yeah, let's try this. Okay, it's working. So that's the try solution. So with the try implementation, the code is really simple. The runtime is that linear with respect to the size of the prefixes we have in terms of both time and space, to populating the try and also to store the try. For the replacement part, it's linear with respect to the input sentence size. So yeah, so that's the try solution to this question 648. Yeah.